Okay, so for the last section of the video, I just wanted to kind of go over the code elements, the use of the strategy pattern, observer pattern, and all those patterns, and why I went about doing that. So the first strategy pattern, the first pattern, sorry, was the strategy pattern, and the first instance where I used this was the blaster. And what I did was I composed the blaster with a controller, and this controller is a current controller, and it switches between either keyboard or AI depending on what kind of blaster is created from the factory. So here, if it's type 0, then you get the controller AI. If it's type 1, then you get the keyboard controller. And that way, whenever I create a new blaster, even if it's recycled, I'm allowed to switch between those controllers. But whenever a new blaster is called, I should say, created, it'll make its own player controller and its own attractor mode. And the reason I did this is because in the case of having two blasters or something on the screen, I wouldn't want the player controller to control one player controller to control all of them. In case if we need to have multiple people controlling different types of controllers, but the fact of the matter for this, even if not that, was just that it didn't make sense to create a factory or just to keep destroying these when the blaster gets destroyed, because the player controller is kind of a static thing where all it does is switches between the two because they're just different input methods. So the only time I actually delete them is when the blaster gets destructed, or when it's marked for destroyed by the Teal Engine at the very end, when the factories clean up. Another strategy pattern which I've used in a lot of my managers actually, in the first one that I've came across it was the mode manager. And the mode manager basically just has it's composed with modes. So the current mode, which is the pointer to the current mode, which just points to either the attractor mode, which is attraction mode.h, one player mode, which is one player mode, and two player mode. And the reason I did this was because at the end of each wave, when a player dies, it has to decide what to do based on the mode. So this is a way of getting rid of all those if player 1, I mean if mode 1, if mode 2. Basically you just set that current mode to the mode, and when this gets called, the decision when the player dies at the very end of a wave, it will call upon the current mode end of wave, which is either, for instance, for player 1, when you do the end of the decision, it'll just get the first player. It won't swap players. It'll just keep loading the wave that it's on. As opposed to two-player mode, when one player dies, it'll swap to the other player, and at the same time, at first, before that, it'll check to see if it's a game over, and then if there's a new score, or to go to the attractor mode. So right there. And that was also that was very, very useful for this kind of stuff. Made my code a lot cleaner. Same thing for pressing enter on high score. Depending on if it's player 1 or player 2, it changes. For instance, in player 1, it would just immediately start attractor mode once you input that new high score if you've achieved it. If not, then it just goes straight to attractor mode. And then in player 2 mode, because we have the other player, at the end of inputting a high score, it would swap players and then play from there, and then see if both of the players are dead, and that's when the attractor mode gets called instead. Player manager also composed with a player, and that's just swapping between players, where player 0 is the attractor mode player, player 1 and 2 are just player 1 and 2. And whenever you swap players, it'll switch between those two, and when you lower the lives by using get player, you get the player and then you set that lower lives. What get player actually does is just return the current player. That way, depending on the player, so for instance, if it's attractor mode, when it dies or when lower lives gets called, it doesn't actually lower its lives. That way it can have an infinite number of lives, because attractor mode, the blaster never actually has a game over, or the player, I should say, the attractor player. And in the sound manager, I use the same thing, where the sound system is is the strategy pattern, where Sound Manager is composed with a sound system, which switches between an audible system or a silent system. And in the same way, it just calls the methods play blaster sound, and it will call the current sound systems play blaster sound, which in the audible system is actually playing something, and in the silent system is just referring to doing nothing. And that's pretty much it for the strategy pattern. The observer pattern first came when I was using the blaster, and that has to do with the bullets. So when a bullet gets created, it'll set bullet fired to that bullet. And when that bullet dies, it'll refer back to the blaster and say to destroy that bullet and set it to null. That way it knows that it can fire again, whether it's AI who continuously fires or the player pressing space. Another area where I use it is the Centipedes factory. I had a list of alive segments, which is could be considered the observer pattern in the way that each centipede body segment and head segment is registering itself to this list, which is the alive list. And basically, when I call recall all segments, it'll get all the alive segments, or all the centipede heads and centipede bodies that are registered to the alive segments, and it'll mark for destroy each one of those whenever I want to clear a wave and the player dies. Another one is the mushroom field itself. Each mushroom field has references to the mushrooms, and when a mushroom dies, it'll actually call its field and say to destroy itself, or it'll give it the coordinates of the mushroom that's being destroyed, and then the mushroom field itself will destroy the mushroom and set the grid position to null. That way the field knows that there is no mushroom there. For the Sybil pattern factories and the singleton pattern, I use them together for every single factory, because it would make sense that there's one factory creating one factory creating the mushrooms and one factory creating the centipede, etc., etc. Each ones are singletons because there's only one of them, and each one has a create mushroom field, create mushroom, for instance, in the mushroom factory, and then it'll recycle those mushrooms by putting them in recycled items. And for every single item that gets destroyed and spawned constantly, I have a factory. So the explosions, the spider, the scorpion, the flea, the head segments, body segments, the blaster, the mushrooms, anything that constantly gets deleted, or I should say marked for destroyed and then respawned. Singleton pattern I've also used for other things that are what the name says, singleton, where there's only one. So the wave manager, there's only one thing that's in charge of incrementing waves or loading waves, loading files, etc. Same for the sound manager, there's only one sound manager, even though there's multiple sound systems. Same thing with the player manager. It wouldn't make sense to have more than one player manager. One is enough. And the centipedes themselves are linked to each other, so that there's linked movements, and it's derived from a centipede segment of the base class, their subclass. The mushroom field itself, like again I showed, does have references to the mushrooms, and it does have counters to minimize work. Specifically the amount of player side mushrooms when it's within, say, the start of the player side mushroom area, and then the bottom, this grid X is actually Y, because it's rows and then columns, but it gets called, and then it checks the amount of player side it checks to see if it's created within the area or destroyed within the area, and then add one or subtract one correspondingly. And then the wave control does have inhuman readable text file. It's read only once, as shown in level 1. It monitors game, triggers appropriate events. I just showed the player class, which player management, which has the players which do different things depending on which player it is, such as updating the HUDs, updating their own scores, their lives, their waves, etc. The text display is the flyweight pattern. It's the base you've given us, so I don't think I really need to explain that. Um, the sound manager I've shown does use the silent sounds, and it's based on the game mode, because when you switch from one game mode to the other one, it'll switch that sound manager. And then the high scores I've already showed that it's read only once, but it's manipulated with the list in the actual which I put it in the wave manager, the list of high scores right here, and it updates when a new score is entered only. It doesn't bother updating if no new score is ever reached, because it wouldn't make sense to update a file that doesn't need to be updated. And that's pretty much it for code elements. I think I've at least tried to use these patterns as many times as I could. I think that as patterns go, I've pretty much used one for every single manager or object that needs to have a pattern, such as strategy pattern and observer pattern. And that's pretty much it. Thanks for watching the video. Sorry it was a long one, but I wanted to try to fully explain everything. Hopefully I did, and thank you.